In this video, we're going to talk about basic domain and range, interval notation for describing our domain and range, as well as a relation. So a relation is kind of the first thing that we need to look at when we're dealing with functions, and that represents just any set of ordered pairs. So that could be finite or infinite, but the domain and range help us describe the different parts of a relation. So the domain is the first component in our ordered pairs, or the x value, the input. The range represents the second component in our ordered pairs, or the y value, the output. So if we look at how domain and range is written, early on in math and algebra courses, we are typically describing it like this. So we're using the less than or greater than signs. So this would be for some continuous functions where the graph continues, it's connected all the way through, there's no breaks or specific points. So this says that x is anywhere between -7 and 0. It can include 0, but it can't include -7 because we have the or equal to sign here. For range, this example shows that y is greater than or equal to -3. So basically it's anywhere from -3 to positive infinity. Often, as you get further into your math courses, especially into pre-calculus, calculus, and a lot of your higher level courses, you're mostly only going to see domain and range written in interval notation. And we use these brackets and parentheses rather than less and greater than signs. So it's kind of written like an ordered pair. And the difference between these two is that the bracket represents that our domain or range includes that value, and the parentheses means it does not include that value. So this example here, -7 is not included in our domain. But it's anything greater than -7 up to and including 0 because there's the bracket. And that matches with what we have here. For the range, again, we say that y is greater than or equal to -3. So -3 is included. There's our minimum value. And our maximum value is infinity. But we have to use parentheses with positive and negative infinity. Because again, the bracket means that exact value is included in our domain or range, and since infinity is not an exact value, then we can't say that y equals infinity. We can say that y goes to infinity, so we have to use parentheses with that. If we are talking about domain or range for discrete functions, so we don't have continuous line, and that doesn't mean straight. It just means that the line is connected, and we only have specific points. Then we have to list out those specific points from least to greatest. So our domain includes only these x values. Our range includes only these y values. And this doesn't necessarily mean that -2 and -4 go together as an ordered pair, and 0, -1, and so on. We just have to write it least to greatest. So in this example, on this graph here, along our x-axis for our domain, we see that it is continuous. It's connected all the way through. As we go to the left, the smallest value for x, well, there's this arrow here, and even though it looks like it goes straight up, or it's going to eventually go straight up, it does go forever. It's just going to go really slowly towards negative infinity for x. And then the same thing to the right, as x gets bigger, it's going to go towards positive infinity. So we would say that x goes from negative infinity to infinity, but the cleaner version, interval notation, we could have negative infinity, comma, infinity with parentheses on both ends. But an easier way to say that would be just all reals or all real numbers. And then for our range, our y value goes all the way down to, there's 2 points here where it gets to y equals 0. And then as we increase, we've got arrows going up towards infinity. So our range is going to be 0 to infinity, or we could use interval notation there with a bracket and parentheses around infinity. One last example here. These are the standings at the end of the year in 2009 for the AL Central in Major League Baseball. And you notice that 2 sets of teams had identical records. It was pretty odd way to end the year for those teams. So let's take a look at the teams and the number of wins they had at the end of the year. So recall that a relation ties together the first component and second component, the domain and range. So if we consider the relation between the teams and the number of wins they had, and that'll be our teams is going to represent our domain, and number of wins is going to represent the range. So we can still set up ordered pairs even though we don't have numerical values for our domain, because there's still a relation between the two. So we write it like a normal ordered pair. I just wrote it in order of what the standing showed on the previous slide. So you see that Minnesota relates to 86 because they had 86 wins, and so on. So then if we want to state the domain and range for this relation, well, this is not continuous. There's 5 distinct points. So our domain, we have to list out all the values in our domain. And again, it's not numerical, so we want to go in alphabetical order. So we use our squiggly brackets and we just list out our 5 teams. And then for our range, we've got 5 numbers there because we have 5 teams, but we only have 3 different numbers. And so if we already have 65 included in our range, it doesn't make sense for us to write it again. So we're just going to list out each number that is shown in our range.